This row actually doesn't change, and don't forget that this is the pivot element. Now, above the pivot element I have this row here, but above that is 4. So I don't want to have 4, I want to have 0, and so I multiply this row here by -4, and I add this row, so I add the third row to the second row. So -4 times 0 is 0, plus 3 is 3, -4 times 0 is 0, plus 4 is 4, -4 times 1 is -4, plus 4, 0. That's what I wanted to achieve here. -4 times 0, 0, plus 0, 0, -4 times 0, 0, plus 1, 1, and -4 times 1 is -4, plus 0 is -4. I continue the same process. Here you see 1, here you see 3, so I want to create 0 here, 0, and to create 0 I multiply this row by -3 and I add it here. So for example, I will have -3 times 1, -3 plus 3, 0, so I would write 0 down here. I will have -3 times 0, 0, plus 3, 3, so I will write 3. So if we do the same process like before, we will get here 4, 3, 0, 1, 0, -3. Again, we follow the procedure that we did before to find Zj and delta Z for these rows. So we have 0 times 4 plus 0 times 3 plus 3 times 0, and we have 0 here, the same 0, but here we have 0 times 0 plus 0 times 0 plus 1 times 3, so we have 3, again here is 0, and again it's 0, and this is 3. Now we substitute Zj from the corresponding values of the objective function, of the coefficients of the objective function. So 2 minus 0 is 2, here again is 2, 0, 0, 0, minus 3. So let's see here. Is that the last table of the simplex method? No, because we have positive elements. We have 2 and 2. We have -3 and zeros. Everything is okay here, but I continue having positive elements, and it means that something has to be substituted here to optimize even more the value of the objective function. So we can take this or that. I take this one, so this is the column that I will substitute, and then remember that I have to divide here the numbers. And how do we do the divisions here? Did we write? Yes, here we must write also the corresponding numbers that were created are 8, 9, 8 and 1. They were created in the same way that we created all the row. We multiply for these numbers too, and then you remember that I have to divide the corresponding numbers. So I have 9 divided by, this is the column that is of interest to me, so 9 over 4, this is 9 divided by 4. Here I will have 8 divided by 3, and here I have 1 divided by 0, and that's infinity. So I'm taking the least of these three, and the least of these three, the minimum is 9 over 4, so that will be the corresponding row. Now at the intersection of the column and the row I have the pivot element, and the pivot element is 4. Remember that the pivot element that I found before was 1. So first of all, I continue. I have third table of the simplex algorithm here, and how do I create this table here? Again, I must write something like the basic variables, and here I will have cj, and again I will have 2, 2, 3, 0, 0 and 0. Again I will have here x1, x2 and x3 and s1, s2, s3. Again I will have d, again I will have d over a. Now what happens here is that first of all, as you see from that table, I have to substitute what? I have to substitute s1 by this variable here. This variable here is x1, so I will replace s1 by x1, and when I'm writing down the basic variables here, I will have x1 with the corresponding coefficient 2, s2 with the coefficient 0, and x3 with the coefficient 3. Here it will be zj, and here we'll have delta z. Also, remember that we start with the pivot element, but I don't want to have 4 here, I want to have 1. In order to have 1, I have to divide all this row by 4, so that I have 1 here and whatever comes up for the other elements of that row. So when I divide, I get actually 1, 3 over 4, 0, 1 over 4, 0, minus 3 over 4, and 9 over 4. Then from 1 I have to create zeros below, so it means that here forget that row, and in the place of that row I have this row here, and I want to create 0 below, and that's 0, so I don't have any problem with that. How do I create 0 here? I multiply the first row by minus 3, actually not that row, I multiply now that row by minus 3, and add the result of that row to the previous row. So I have, for the second here, I have 1 times minus 3 plus 3, 0. Then I have minus 3 times 3 over 4 plus 4. The results that you get are 0, 7 over 4, 0, minus 3 over 4, 1, minus 7 over 4, and 5 over 4. And for the third one, actually I don't need to change something because I have 0 here, so I write down this row exactly as it was before. Now again I multiply and I find the corresponding zj. This is 2, this is 3 over 2, this is 3, this is 1 over 2, this is 0, this is 3 over 2, and then I subtract. 2 minus 2 is 0, this is 1 over 2, so 2 minus 3 over 2, here we have 0, minus 1 over 2, and then 0 and minus 3 over 2. Now as you see, I continue having a positive number here, so even that table, the third table, is not the final table of the simplex method. So I have to do another round again, and I know here this is the column that I have for the variable x2, and then I divide d by the elements of that column. So if I divide this by that, I will take 3, 5 over 7, and infinity. Of course I need the list of these 3, and the list is that, so I have that row and that column, and now that's my new pivot element. So it means that s2 must be substituted again by this variable, and this variable is x2. So I'm starting the next table. Again, I have the basic variable. Here I have cj, again x1, x2, x3, slack 1, slack 2, slack 3, and d over a. Okay, so here again I have the coefficients of the objective function. That's 2, 2, 3, and 0, 0, 0. Again, now remember that I have to change that variable, and so x1, I have x1 here, then I change s2 by x2, x2 together with the value of the objective function, and x3. x3 is the line I had before, it doesn't change. Now again I start, don't forget that here the pivot element is that element here, but in the place of the pivot element I want 1, so I divide all the elements of that row by 7 over 4, or if you want, you multiply by 4 by 7. And in the place of that I will have 0, 1, 0, minus 3 over 7, 4 over 7, and minus 1, and here 5 over 7. Don't forget that from that row here I have to create zeros for that and that. This one has 0, so I don't need to change it. This is 0, 0, this is 0, 0, 1, 0, 0, 1, and 1. But I multiply by minus 3 over 4 and this one, and I add it to the first previous line, and I get my new numbers here for the first row, and the new numbers are 1, 0, 0, 16 over 28, minus 12 over 28, 0, and 48 over 28. Now if we calculate zj, you remember that 2 times 1 plus 2 times 0 plus 3 times 0, that's 2. Then 2 times 0 plus 2 times 1 plus 3 times 0, again 2. This is 3, this is 2 over 7, this is 2 over 7, this is 1. And then delta z is to substitute 2 minus 2, and that's 0, 2 minus 2, that's 0, 3 minus 3 is 0. This is minus 2 over 7, this is minus 2 over 7, and this is minus 1. Minus 1. So as you see here, I have negative numbers at the last row. I have negative numbers, as you see here, or zeros. So that's the last table that I get from the simplex method, and from that last table I can get my solution. So the solution is x1 equals 12 over 7 and x2 equals 5 over 7 and x3 equals to 1. You can see the corresponding elements here. So the final solutions are 1, 2, 3, x1, x2, x3, and if I substitute that all of them on the objective function, I find the corresponding value of the objective function, that's 55 over 7, and this is the maximum value of the objective function. And here the solution is integrated.